In this video, we will explore normalization, which is a data pre-processing technique. We will also examine a coding file that uses the iris dataset. When examining the data used in artificial intelligence, we often find various features, represented by different X values. However, if these features have different ranges of values, the results can be biased towards certain data. For example, when performing multivariate linear regression analysis with features like age and income may inherently have larger values compared to age, which can exert a greater influence on the results. However, it does not necessarily mean that income is more important than age as a feature. Therefore, it is necessary to adjust the values of these features to a consistent level, and this is where feature scaling comes into play. As seen here, x1 and x2, which have different ranges, will have a uniform range after feature scaling. There are two commonly used methods for feature scaling: normalization and standardization. First, let's take a look at normalization, a method used to transform the sizes of features with different ranges into a consistent range. Generally, normalization transforms the values to a range between 0 and 1. To achieve this, we subtract the minimum value from each value, x, and then divide it by the difference between the maximum and minimum values. As a result, the minimum value becomes 0, the maximum value becomes 1, and the remaining values fall between 0 and 1. In the table below, you can see that after normalization, both age and income have been transformed into the same range between 0 and 1. On the other hand, standardization is a method that transforms values into a standard normal distribution with a mean of 0 and a standard deviation of 1. To standardize the values, we subtract the mean from each value, x, and then divide it by the standard deviation. As a result, the values are transformed into a new scale where the mean becomes 0 and the standard deviation becomes 1. In the table below, you can see that after standardization, both age and income have been transformed into the same range with a mean of 0 and a standard deviation of 1. Then, based on the previous coding file that classified the iris dataset using a support vector machine model, let's add the normalization process. You can download the Jupyter Notebook file from GitHub and run it directly. First, we import the necessary libraries, NumPy, Pandas, and train test split. Additionally, we also import the min-max scalar library for normalization. Next, we load the Excel dataset. Normalization can be easily performed using the min-max scalar command. For normalization, we only need to apply it to the features, which are the x values. Therefore, we assign the y data as it is from the loaded Excel file. Regarding the x data, we use the min-max scalar to perform normalization, and then assign the normalized values. As a result, we can see that the x data has been transformed into values between 0 and 1, as shown here. After this step, the subsequent process remains the same as the previous support vector machine classification model. Therefore, you can compare the accuracy with and without normalization to determine whether to use normalization or not.